ICMA 2023. We start with the first technical session of the day. Today we have in our midst a very eminent scholar, eminent scientist to head the session today, the first session. Before I tell you about him, the first remarkable thing that one of his recent achievement. So I want to mention that, and then I will go to the introduction part of it. Every year, we know the Stanford University, which is a well-known foreign university, publishes a list of scientists. It says top 1% world's top scientists, then 2% world's top scientists. So likewise, they publish a list of world's famous scientists of the year. And our resource person, Dr. Surapati Pramanik, he has been listed as one of world's top 2% scientists. This is very, very, as Indians, we have to feel proud. As mathematicians also, we have to feel proud that one of a mathematician, one of our Indian, is being listed as one of the world's famous scientists. So with this note, I would like to introduce to the audience who are offline, and many, I know hundreds of participants are participating online. This session is streamed, live streaming is going on. So I have the pleasure of introducing such an eminent person. So our resource person, Dr. Surapati Pramanik, is a assistant professor in the Department of Mathematics, Nandalal Ghosh BT College, which is in West Bengal, near Kolkata. Sir has a very good record of not only publications, research profile. So his research profile is very rich. It will take a lot of time to go through every details, but let me tell few things in short. So professor holds 2 PhD degrees. He holds 2 PhDs. We know how hard it is to get a PhD degree. He holds 2. One in mathematics and another in education, mathematics education. So his PhD thesis title is Fuzzy and Intuitionistic Fuzzy Goal Programming. And another PhD thesis title is Contemporary Mathematics Education at Secondary Level in India, China, and USA, a comparative evaluation. Sir knows several languages, and his fields of specialization are soft computing, operations research, multi-criteria decision making, fuzzy sets, neutrophotic and hybrid neutrophotic sets, and mathematics education. He has teaching experience of 15 years, has traveled throughout the country, several parts of India, and Sir has published 7 books and has edited 2 books. He has also published more than 25 book chapters, and the number of publication he has is more than 150, Just looking at his Scopus profile, I found that more than 52 papers he has published in Scopus Index journals. So his total citation, number of citation in Google Scholar as of today is 6,235. Last year, just a year ago, when I approached Sir for having his name as an external examiner, the citation was 4,000. Within a year, it has come to 6,235. His H index is 42, IT index 135. Sir has presented several papers in conferences, nearly 78. Number of international seminars, 23. National seminars, 19. State level seminars, 36. So the list goes on. He is an editorial member in several journals, 81 journals, and as reviewer in 116 journals. So the list goes on. He has such a strong profile, and that is the reason why he is being indexed as the world's top scientist. And that's we are privileged to have Dr. Surapati Pramanik as a resource person for this session. When I approached him just a few days, like 1 week or 10 days before, he immediately accepted our invitation, and everything was arranged within a week. Okay, so we are happy to have Professor Surapati Pramanik as the resource person on this campus. So we wanted to him to visit our campus to have tie-up with our department, because our department, mathematics department, Sacred Heart College, has a very rich profile in research. So we wanted to make a tie-up, and he is a well-known researcher. So he will help us out in many ways. The young researchers, other colleges also, young researchers, you can approach him for any kind of help. Uh, so that is the reason why we wanted to have him here. So on behalf of Sacred Heart College, the management, especially on behalf of the Department of Mathematics, I extend a hearty welcome to Dr. Surapati Pramani. Warm welcome to you, sir. I request Dr. A. George Marie Selvam, the PG Head, Department of Mathematics, to honor our resource person with a shawl. Okay, we don't want to take much of his time, so it is now time for the resource person, Dr. Surapati Pramanik, to deliver his talk. So please, sir.
Good morning to all present here. President of the session, convener, Dr. D. Ajay, and I am paying homage to very dynamic personality, Reverend Dr. D. Maria Anthony Raj, Principal of this college, Reverend Dr. Thupil Anand, Vice Principal, showing respect to Dr. B. Anthony Xavier, President of ARRM Society, Dr. A. George Maria Selvam, Chairman, ICMA 2023, Dr. D. Ojai, Convener, ICMA 2023, Dr. S. Siram, Co-Convener, ICMA 2023, and Head Department of Mathematics, and PCAS, Mr. Thaniga Gajalam, Honorary Secretary, ICMA 2023, paying tribute to keynote speaker, Mr. Dr. Jagadish Kumar, MS, Head and Associate Professor, Department of Mathematics, Vellore Institute of Technology, Vellore, and other dignitaries present here or online mode, and all mathematicians, professors, participants, research scholars, and professionals, and brothers and sisters of Tamil Nadu who are present here or online mode and listening to me. I am bowing down my head to you all. Heartiest greetings to all, and as always, like past, I remember all my teachers, including my parents, whose contribution is the main part and parcel of my life, and to be here as a resource person. Also, thanks to all fraternities of the Sacred Heart College organizing committee. Today, we all have gathered here to participate in international conference on mathematical science and application 2023. I am highly honored and feel privileged as the organizing committee has invited me as a research person. Heartfelt thanks to all dignitaries. This college has founded by far-sighted missionary from Spain, Reverend Joseph Carnio SDP, in 1951. It started functioning with 10 teachers and 81 students. After a short period of 7 decades, it becomes postgraduate program. And its Golden Jubilee was held in 2001. In 2006, it got NAC A. Now 2007 Autonomous College status. Inter college marvelous achievement in 2007 and in 2017 95 rank in India. It offered quality of education. It always undertook a forward march. It is here healthy relationship between faculties, staff, students, and related persons. And Department of Mathematics is a very proud department. It has started PhD from 2002 and also MPhil from 2020. A great history for mathematics. I believe firmly that education imparted at Sacred Heart College molds students with academic excellency and intellectual and ethical privileges. I would like to thank again the members of the organizing committee and all the members of the Sacred Heart College to invite me as a resource person. Thank you. Before now I start my presentation. Do I start my presentation now? All right, ready? Thanks. It is better I go there and present my paper. Actually, I believe mathematics is very simple. And mathematics always follows the simple steps. And I will present very simply what I understood. Okay. Uh, Actually, here I want to present interval pentapartition neutropic sets and their properties. This paper you can find in archive. Okay. Okay. Thank you. Actually, I will present what is neutropic set, five sets, etc. in a very simple way, and we will present interval pentagon neutropic set in a very simple way, and where it can be used. Jare founded the five sets in 1965 to deal with subjective implicit data. Five set has single membership function, which belongs to 0, 1. In 1986, Attorney proposed the entropy phi set, which is an extension of Jade's phi set by incorporating non-membership as an independent component. Although the entropy phi set theory has been established and generalized, it cannot deal with all uncertainties in many real-world problems. Certain types of uncertainty cannot be handled, such as indeterminate and inconsistent information or data. To deal with these problems, Maharaj in 1998 introduced the Nutrivic set, which is characterized by three independent membership functions, namely truth membership function, indeterminacy membership function, and falsity membership function. And Nutrivic set is a very helpful tool for dealing with incomplete, indeterminate, and inconsistent information. Relation between the classical set, Fuzzy set, interval Nutrivic Fuzzy set, and Nutrivic set is shown in figure 1. That is, classical set means the Cantor set, then Fuzzy set, then Nutrivic Fuzzy set, then Nutrivic set. They are very simple relation in this way. You can present in another way also. You may include interval Nutrivic set here, but I just simply present in this form. Classical set, that is classic set, then Fuzzy set, then Nutrivic Fuzzy set, then Nutrivic set. How? In a classical set, the elements get two numbers, 0 or 1. That is, either the element belongs to the set or does not belong to the set. If belongs to the set, its characteristic value is 1. If does not belong to the set, then its membership value is 0. That is, we can present in two ways, 0 or 1 in classical set. 0 means non-membership, that is, does not belong to the set. And 1 means the set is completely, the element is complete in the set. Then Fuzzy set, grade of membership. Here, degree of membership and degree of non-membership means 1 minus membership degree. And in Fuzzy set, membership degree is dependent on, non-membership membership is dependent on membership function. In intuitive Fuzzy set, we see that non-membership function is independent of membership function. That is the difference between Fuzzy set and intuitive Fuzzy set. And in Nutrivic set, all the membership functions are independent. Wang et al. In 2005 defined interval Nutrivic set as a subclass of Nutrivic set by considering that the truth membership degree, indeterminacy membership degree, and falsity membership degree are independent and assume values from the sub-unity interval 0, 1. In Nutrivic set, it can any values in non-standard interval 0, 1, but in single value Nutrivic set, interval Nutrivic set, we take the intervals and assume values from the sub-unity interval 0, 1 in interval Nutrivic set. This is the figure for interval Nutrivic set. And now we come in 2005 in a conference. Actually, single value Nutrivic set was first introduced. After that, in 2010, Wang et al. Defined single value Nutrivic set by restricting the degree of truth, indeterminacy, and falsity in 0, 1. And we can see in this form. This is a Nutrivic cube actually, where we see that the point 1, 0, 0 and 0, 0, 1. Okay. We see the 2 point M001 and N001 are cube sets, because 1, 0, 0 means the element completely belongs to the set, and 0, 0, 1 means completely false, that is do not belong to the set. That is the points 1, 0, 0 and N001 is cube set, cube points or cube sets. Points on the line Mn represent the Fuzzy sets. Because here we see that the line Mn represent Fuzzy sets, because 1, 0, 0 means in this word from 1, 0, 0 to 0, 0, 1, and if you reach here completely false, that is not in the set, and from here to here, from the line Mn is represent the Fuzzy sets. Here Mn, this line represents the Fuzzy set, because membership function from 1 to 0, it goes to from 1 to 0, and non-membership 0 to 1. points in the region O, M, P, N, O. This is O, this is P, N, M, O. Region behind the shaded triangular, the points in the region O, M, N, P, O, that is the region behind the shaded triangle M, N, P represent unit Fuzzy sets. Points in the unit cube covers simplified neutropic set, that is single value neutropic set. Here all the points in the unit cube means the points of the single value neutropic set, or simply we can say simplified neutropic set, the term also in the literature. Therefore, here all the sets are covered here, that is Fuzzy set, cube set, Fuzzy set, intuitive Fuzzy set, and single value neutropic set. And if you take this is non-standard form, then also it covers then neutropic set also. Now, after this, Chatterjee et al. In 2016 defined quadripartition single valued set by utilizing the concept of single valued neutropic set, 4-valued logic, and n-valued refined logic. And n-valued refined logic was introduced by Professor Mahandeche in 2013. Then, quadripartition single valued neutropic set is characterized by 4 membership functions: truth membership function, falsity membership function, unknown membership function, and contradiction membership function. Therefore, we see that there were truth, falsity, and indeterminacy, but here unknown membership function and contradiction membership are present here instead of indeterminate membership function. And these 4 components constitute the single valued neutropic set, and it was defined in 2016 by Chatterjee et al. Then, Pramanik defined interval quadripartition neutropic set IQNS by utilizing the concept of interval neutropic set and 4-valued logic and n-valued refined neutropic logic and quadripartition neutropic set. Here another component was added, and the form will be in this form: T, C, U, F, and each point W belongs to W in this form. Truth membership function will be in this infimum of TH and supremum TH, and contradiction, this is, and falsity. Actually, if you go back there, these 4 functions here is in 0, 1, but here is interval form. That is a difference only. And if you take the supreme value of the supreme, it is lies between 0 to 4. And if you see the illustration of IQNS in R1, we have this form. Actually, this is an extension of actually interval neutropic set in this form. You go back. Not controlling here. Here interval neutropic set. Okay. Now, if you use this in quadripartition, then the figure will be in this form. The figure will be in this form. Okay. And the truth membership function can be defined in this form: infimum of TH and supremum of TH, and other function can be defined in this form. And this is falsity memory function, and CH and UH can be defined in this form. Then again, this is the 4 function: truth memory function, falsity memory function, unknown memory function and contradiction. And we write them in this form. Truth memory function in this form, and unknown function in this form. Then this is the 4 function, that is 4 in-memory function, truth memory function, falsity memory function, unknown memory function, and contradiction memory function. In this way, we can define interval quadripartition Neutrovic set. Now, Pramanik and Maulik in 2020 proposed a single-valued pentapartition Neutrovic set by splitting the indeterminacy memory function into 3 independent components, that is contradiction, ignorance, and unknown membership. To deal with uncertainty that includes ignorance, indeterminate, incomplete, and unknown information. And then, actually, component indeterminacy means contradiction, ignorance, and unknown. These 3 constitute the indeterminacy. Therefore, indeterminacy memory function replaced by 3 independent component: contradiction, ignorance, and unknown. Then uncertainty takes in this form: truth, indeterminacy, falsity. It is actually a Neutrovic set or single value Neutrovic set. Then we split indeterminacy into 3 parts: unknown, ignorance, and contradiction. And then the uncertainty will be in this form. Component of uncertainty means here contradiction, ignorance, unknown, false, and truth. There are 5 components. Now, this is the basis of defined pentapartition Neutrovic set. Then we can define, Maulik and Pramanik defined in this form. These are 5 membership function, and their supremum lies between 0 to 5. And if we take particular value, then it becomes a single valued Neutrovic pentapartition, single valued pentapartition Neutrovic number. There are some preliminaries for pentapartition Neutrovic set. If K and L 2 pentapartition Neutrovic sets, then K is a subset of L1 if and if these properties are held. Similarly, the intersection is defined in this form: minimum, this is minimum, and max, max. If we consider a union, then defined in this form: max, max, mean and mean, and mean and mean. There will be mean also. Similarly, complement is defined in this form. We see that this is false, comes to the place of truth value, and UK replace CK here, and GK 1 minus GK, and CK goes to here, and truth value goes to false value. In this way, complement is defined. Now, we are going to define the interval pentapartition Neutrovic set. Assume that W is inverse of discourse, then T, and interval pentapartition Neutrovic set over W is defined in this form. There are 5 components: TD, CD, GD, UD, and FD. And for each W belongs to W, we have this form. Then TD, CD, GD, UD, and FD are the degree of membership of truth, contradiction, ignorance, unknown, and falsity. And they are defined as for similar as interval Neutrovic set in this form. This is infimum supremum in this form. And sum of the supremum lies between 0 to 5. Okay. This means that in interval Neutrovic set there are only truth, false, and indeterminacy. Here there are another 2 functions, and we take them in interval form. That's why it is interval pentapartition cubic set. It also can be called single valued also may be called. And the figure will be in this form in R1. Now, some example, assume that W1, W2, W3, where W1, W2, W3 denote respectively capability, startworthiness and price. The values of W1, W2, W3 are in 0, 1. They are obtained from questionnaires of some domain experts. Their option could be degree of truth, degree of contradiction, degree of ignorance, degree of unknown, degree of false, that is 4. And in that case, interval interpretation set can be defined in this form. We see that these are interval forms, and similarly D2 can be defined in this form. Take D1 in this form and D2 in this form. Then null IPNS can be defined in this form. The first two parts are 0, 0 and last three part 1, 1. Similarly, unity of interval pentapartition is defined in this form. Let's see that here 0, 0 and all the three are 1, but here the first two are 1, 1, 1, 1, rest are zeros. Now, some definition of containment. If D1 and D2, if D1 is subset of D2, if and only if this, the relations holds. Definition this way. Inferior of TD1 less than equal to inferior of TD2 and supremum of T less than equal to supremum of second set. In this form we define. We see that the first two are same type and rest of the three are same type. In this way, we define subset D1 subset of D2. Similarly, D1, D2 are equal if these two holds. Now, complement of a set, interval pentapartition cubic set. If this defined in this form, then complement is defined, we see if we take D in this form, then D dash, that is complement D in this form, and the relation between them is shown in this way. That is truth value replaced by its falsity value, and CD dash equal to UD, and GD dash equal to 1 minus supremum of GD, and supremum of GD dash equal to 1 minus infimum GD, and U dash equal to CD and F dash T equal to FTD. In this way, we can define the complement of a interval pentapartition cubic set. Okay. Sorry. Then we see that complement of T dash, that is sorry, complement of D, that is D dash, is defined in this form. This is a 5 component and corresponding 5 component in this form, and each is defined, that is T dash is defined in this form false. That is, this is the first component of D dash will be the falsitive. Then CD dash will be this unknown function. And for CD dash, this is unknown function. And for GD dash, it will be in this form, 1 minus supremum of GD, and supremum of GD dash equal to 1 minus infimum of GD. And UD dash, that is, this is replaced by CD. And for FD dash equal to truth value. That is, reverse this come here. That's why for complement, it is in this form. The falsity membership function comes to the truth value, and truth value comes to the falsity. And this UD dash replaced by CD dash, CD. These are replaced, and these actually in this form. Now, if we consider a numeric example, you can find in this form. Here 4.75, you see that here 4.075, and this 1.15 we are shared, and here take the 1 minus supremum, like this, and this goes to this. That is, in this form we can define complement. Similarly, for intersection of two interval pentapartition nitrovic set, if we take D1 and D2 in this form, their intersection can be defined in this form. Take minimum of this in form of TD1 and TD2, and take minimum of supremum TD1 and supremum TD2. In this way, we can define intersection of two pentapartition nitrovic set in this form, as in the case for interval nitrovic set. But here the difference is that there are many components. There are 3 components. Here there are 5 components. That is the difference, main difference. And if we consider example 1 as before, we can define in this form. And result. Similarly, union can be defined in this form. If D1 is in this form and D2 in this form, then D1 union D2 is defined max of this and max of this, max of this, max of this, minimum of this, minimum of this, in this form. In this way, we can define union. And if we take example, numerical example, we can do it very easily, okay? That is a very simple definition. In interval nitrovic set, we extend it for 5 components, and we give a numerical example in this form. Now, theorem 1, for any 2 interval nitrovic sets, D1 union D2 equal to D2 union D1, and D1 intersection D2 equal to D2 intersection D1. And it can be proved very easily following the defined rules previously. D1 union D2 means in this form. This is a form. And if we replace this in this form, that is maximum TD1, maximum TD2, if we replace this in this form, just then we see that this is the definition of D1 union D2. Replace this, max this means max of this and this, no problem. In this way, we see that D1 union D2, D2 equal to D1 by using simple definition. Similarly, for the part of D2, D1 intersection D2, a definition of D1 intersection D2, we have this. Then just take this in this form. Take the infima of TD2 at first, then in this form we can write, and ultimately we see that this is actually D2 intersection D1. That is D1 intersection D2 equal to D2 intersection D1. These rules are very simple, but I just show. Similarly, for any three interval pentapattern rules as G1, D2 and D3, we have the result D1 union D2. There will be another bracket. The results will be D1 union D2. This result is same as D1 union first bracket union D3 equal to will be D1 union of D2 D3, and this can be also proved using the very simple definition. Sorry, this bracket will yes. Thus we see that we use simple definition of union, nothing more. At first we take the union of D1 D2. See. School, but point, I want to show the point.
You, sorry, unfortunately, we are not
Arrow.
fine, sir.
Light edge this. Okay, okay now. No. Okay. At first we use the definition of D1, D2. After this you take union the D3. Then we have this result. Okay. At first D1, D2, then union D3, we will have this. Then actually we can write in this form, and after that whole we can write D1 union D2 D3. Similarly, for the case of intersection D1 intersection D2 D3, this can be proved in this form D1 intersection D2 intersection D3. How? Just take the definition of D intersection D3 in this form, then again take the intersection with D1, then with this form. Ultimately, this is the form, and we have this. Now, for any two IPNS D1 and D2, D1 union D1, this is the basic results, and we can prove these results with the basic definition of union and intersection. For this, at first, we take the definition of intersection. After this rule, then we take union, and we have this form. That is, at first D1, this is D1, and this is the definition of intersection. Then we take the union, and we have this, and we see that this is the actually D1. So D1 intersection, union D1 intersection D2 equal to D1. Similarly, we can prove this result also. Here, at first, this is the definition of D1, the intersection of this D1 union D2. After this, we combine with this in this form, and we see this. Ultimately, this is actually D1. This is very simple result, D1 union D1 equal to D1, D1 intersection D1 equal to D1. This can be proved very easily using the definition of D1 union D1, very simple, same. So no need to discuss this. Similarly, for intersection, we see that these are two same genus. So D1 intersection D1 equal to D1. Then D1 intersection 0, the unit element of IPNS, this is 0, and D1 union unit element equal to unit element. This kind of basic element, basic definitions. D1 intersection 0, this means 0, this is 0, and using the definition, we have this 0. Basic results. Similarly, if we take the union, this should be 1. This is infimum, supremum, infimum, supremum in this way. Max of this is this. Okay. So this is the basic rule definitions. Then D1 union element of 0 D1 intersection is 1. Oh, sorry. Then repeat. D1 intersection unit 0 element gives 0, and D1 union unit element gives 1 in this form using the basic definitions of 0 and unity. And if we take the reverse result, also union 0 union D1 union 0 equal to D1, and D1 intersection unit element equal to D1 using the basic definition of 0 and 1 unity. Because this max of this, max mean this infimum. Similarly, D1 intersection unit element equal to D1. Now, for any interval pentation network set D1, if you take this complement of complement, this gives our element 1 in this form. Assume that D1 is interval pentagonal sets in this form, then take the complement, then the basic definition in this form, and further take the complement, then we see that the basic definition of D1. So, if we take complement of element, becomes the original element D1, set D1. Very basic definition of complement. Now, we need a proposition for another theorem. If A greater than 0, then supremum of A P equal to A supremum P, and infimum of A P equal to A infimum P. If A less than 0, then supremum of A P equal to A infimum P and A infimum P equal to A supremum P. In particular, we have this result. Supremum of P equal to minus of infimum P and infimum minus P equal to supremum, minus of supremum P. If P and Q are non-empty sets, then supremum of PQ equal to supremum of P and supremum of Q, and infimum of P plus Q equal to infimum P plus infimum Q, and supremum of P minus Q equal to in this form. And these the two propositions are related for my next theorem, for our next theorem. For any two interval pentaversion equivalent sets D1 and D2, D1 union D2, if we take their complements, then we have this D1 complements intersection D2 complements. And if we take D1 intersection D2 complement, then we have D1 complement union D2 complement. And all these proofs are very simple, just using the definition of union, intersection, and complement. And you can deduce these results following simple operations. And for that, we have at first take D1 into D2 as given definitions, then we take the complements, and we have this form. And basic definitions. And this we write as equation 1. Then we take D1 complement, intersection D2 complement, and we have this. Take this equation 2. Now we use these two results. Now theorem it will be proved if we can prove that these two results we have to prove. And we prove this using the, for this we assume in from GD1 equal to C1 and GD2 equal to D2. And we see that this. And for maximum this, we see this. By proportion, if you use proportion 2, we have this. In this case, we have D. Then using 3 and 2, we have this. Now, we have these 6 results, and here we have this in 7. Therefore, from 6 and 7, we have this. Then from 1 to 5 and 8, that is, we have to see this is 1, this is 2, and this is 3, and this is 4, and 7 and 8, we have this. That is, we use the two propositions and use them, and we can reduce these results. And similarly, the second part can be proved similar, therefore I left it. Now, for any two interval perturbation reducing sets, D1 and D2, if D1 subset of D2, we see that they are complement reverse. That is D2 complement subset of D1 complement. And using the basic definitions, we have this. So we see that just follow the definitions and you will have the required results. Now, what was the motivation behind this work? Actually, I followed the definition of interval neutropic set by Wang et al. Then follow the pentapartition neutropic set and extend it for interval case, and we have the interval pentapartition neutropic sets. Also, you can, where now for further research, you can take the function in this form. I come back to the original definitions. What happens if we take, this is another form. We take this interval form, if you take another form, you will have another result. So, there are multiple ways to define a new set, okay? Here we simply define interval pentapartition neutropic sets, but you can define more further way. When you replace T, C, G, U in another form or another way, you can have another set. So now there are more than 80 neutropic sets. There are more than 80 neutropic sets I have found in 2021 when I am writing a paper or single value neutropic sets and overview. There are more than 80 papers in neutropic environment. And you can define in this way new sets and develop a new set, okay? So try to develop new set using new idea, and you can really develop a new set and can get the credit. Actually, all the credits are gone to the foreigners because they have thought and did it at that time. But we always think but do not write. At first, if you think something new, write and communicate to the journal. But always we have followed them. Our tradition is to follow the foreigners. They develop, they define, then we apply it for our work. But try to develop new set, define new set, and communicate to the journals. Then you can get the result and you will get the credit. Okay. So try to implement some new idea and try to communicate very quickly, because nowadays all are very busy and are doing new things very quickly. You have new laptops, new reference systems, etc. You can use it, and very short time you can write a paper. So at first develop either Jotero or Mendeley etc. referencing system, and use the artificial systems, all type of helps using internet etc. And write your paper and commit very quickly. Then you will get the credit. Otherwise, you can think, but you cannot get the credit, because all are trying to develop new things. If you late, then they will get the benefit or credit. So I just represent interval network set in a simple way and put some properties. You can have these results on my archive. It will upload it. Okay. Now I will tell something about MCDM, where this set can be used very easily. Few terms I want to tell you. If a new researcher, then it will help them. Where to actually I want to discuss few things of MCDM where the new set can be used directly. Okay. MCD is the study of methods and procedures by which multiple and conflicting criteria can be incorporated into the decision process. And this definition is given by International Society on Multiple Criteria Decision Making. MCDM is two types: multi-attribute decision making, MADM, and multi-object decision making. Multi-attribute decision making, MADM, and multi-objective decision making. Multiple object decision making, when a decision problem has a finite number of criteria or multiple criteria, and the number of feasible alternatives is infinite or given implicitly. That is when the decision space is often continuous. MADM, when the number of criteria, that is attributes, and alternatives are finite and alternatives are explicitly given. That is when the decision space is primarily discrete. Multi-attribute decision making takes place in the presence of multiple, usually conflicting attributes. Multi-attribute decision making models are widely used in real life decision situations. Examples of some multi-attribute decision making: in choosing a job, one may consider salary, work location, promotion, job security, etc. In choosing a mobile, one may take into account their RAM, processor, design, display, size, price, etc. In selecting a car, one may consider price, mileage, design, safety, comfort of the car, etc. While appointing an assistant professor or in an institution may consider the candidate's teaching ability, communication skill, personality, research ability, values, etc. An MADM model is presented with following components: alternatives, criteria or attributes, objectives. Alternatives. Define choices of a action available to the decision maker in a MADM are termed as alternatives, which are supposed to be screened, prioritized, selected, or ranked in a decision making process. For example, in choosing a career, professor, doctor, scientist, and entrepreneur may be possible alternatives of the choice. This is the alternatives. Criterion. A criterion is a measure of performance and the basis of the evaluation of an alternative. Attributes. What is attributes? Attributes are criteria used to evaluate alternatives. Attribute is an inherent characteristic of an alternative. Each problem may have multiple attributes which may conflict with each other. For example, in choosing a mobile phone, RAM, processor, design, display, size, and price could be considered as attributes in MADM. Attributes are two types: benefit and cost. Mileage of a car is a benefit of attribute, and price of a car is cost of attribute. These we need. Then relation between criteria, attributes, and objective. Objectives and objective is something that is to be pursued to achieve the goal. The relationship among criteria, attributes, and objective is shown in the following figure in this form. Any problem? Hmm? For example, a level of comfort is a criterion for the choosing a car. Sitting pace and noise are attributes of the car which can be used to measure the level of comfort. The maximization of sitting space and minimization of noise are objectives of the car choice. Conflicting among attributes. Because of the defined dimensions and of alternatives, attributes may conflict with each other. For example, cost may conflict with profit. Incommensurable units, each attribute has an unit of measurement. For mobile selection, display quality is expressed by pixel per inch, that is PPI. Camera quality is expressed by megapixel. Price is considered by rupees. Customer care may be indicated in a non-numerical ways, etc. Therefore, there is a problem. So we use normalization technique, and in general, normalization technique is used to deal with the problem of incommensurable units. Addition words, almost all methods, MCDM problems, need information about the relative importance of each attribute. The relative importance is usually given by a set of words. And then we can take normalized words, or we have subjective words, objective words, and there are several methods in the literature. You can use them, okay, for determining the words. Now new methods are coming. You can follow literature, okay, and you always use either established words or you can develop for yourself for new methods. And we use addition matrix for them. Addition matrix can be constantly defined ways. This is one form. You can present these defined ways, and you use equation 7. Then you see that there are several ways to present addition matrix. The classical MATM methods generally assume that the rating values of alternatives and the importance of attributes are expressed in terms of crisp values. However, in the classical MATM method cannot present imprecise or vague information, which often occurs while evaluating alternatives over the criteria in a decision process. The impreciseness or vagueness may come from defined sources. Any problems? Uncontrollable information are involved. The price of a new car can be easily determined while the safety or comfort of a car is not controllable. Safety and comfort are usually expressed in linguistic terms such as good, fair, poor, etc. That is, these are known as qualitative data. In some cases, incomplete information are there. In a game, if a player is uncertain of the payoffs to other players, the game is one of the data. How to express the contents of a price of incomplete information? The crudest model is a digital set of, namely as collection of mutually exclusive objects or situations or worlds, one of the which is the actual one. Non-optimal information. Sometimes CRIPS data is obtainable, but the cost is too high. And the decision maker may wish to get an approximation of that CRIPS data. In that case, non-optimal information. Partial ignorance. Impreciseness is attributed to partial ignorance of the phenomenon since one knows only part of the facts. Partial ignorance requires specific tools for representing uncertainty that somewhat contradict a significant part of the probabilistic tradition. Actually, Fuzzy set is useful and effective for presenting different types of impreciseness. For each real value of unit interval represents a membership degree of an element of a fuzzy set, I have already told this. Membership functions belongs to 0, 1 and 1 minus membership function defined as the non-member function of that element. The fuzzy information is related to three value logic, that is true, false, and ambiguous. That is, when fuzzy information deals with the true and false, it is skips. This is generally does not hold for an element with incomplete information. If you see the figure, fuzzy information means certainty. Certainty means truth and false, either truth or false, like this. Or fuzzy information uncertainty, that becomes to ambiguity. Then, Atomishop in 1986 developed the idea of integer fuzzy set. An element of integer fuzzy set A characterized by the membership degree and non-membership degree such that their summation less than equal to 1. If equal to 1, then fuzzy set. If less than 1, then integer fuzzy set. Therefore, certain amount of information, that is 1 minus mx minus nx, remains indeterminate by default, which are called Hessian degree of integer fuzzy set A. But this individual information is dependent on membership function and non-membership function. So, the integer fuzzy information is related to a tetravalent logic where the information could be true, false, ambiguous, and unknown, and can be put in this form. Integer fuzzy information means certainty, true, false, uncertainty, then ambiguity and ignorance. Then, if indeterminacy is considered as an independent component in real life problem, then integer fuzzy set cannot deal with it. If independent component is independent of truth and false. When an expert gives an opinion about a certain statement, that is, he or she may say that the possibility that the statement is true 0.6, degree of false statement is 0.3, and possibility of that he or she is not sure is 0.2. There are some excess ones. Therefore, not possible for integer fuzzy set to deal with this. Example from the medical diagnosis. Sometimes it is difficult for a doctor to make a certain diagnosis when a patient is suffering from a disease. Therefore, he or she will often give an analysis with a degree of truth and falsity as well as indeterminacy, such as 65% of yes, 35% of no, and 25% of not sure. These issues are beyond the scope of fuzzy sets and integer fuzzy sets. So, Maharaj said, first introduce the concept of integer set, as I have already said you. From the physical point of view, to handle intermediate and inconsistent information usually exist in real decision-making situations. Then casualness, the idea that many categories in natural language are a matter of degree, including truth, which is against the Boolean tradition. Then epistemic uncertainty, the idea of representing partial or incomplete information by sets. Possibility theory model logic against the probabilistic tradition. So, we see vagueness means the idea that the extension of natural language predicates lack clear truth conditions. Fuzziness, the transition between membership and non-membership in gradual rather than abrupt. Fuzziness means that a transition between membership and non-membership is gradual rather than abrupt. Then fuzziness and vagueness. Although the terms fuzzy and vague are frequently used interchangeably in the literature, there is in fact a significant difference between them. Specifically, a proposition P is fuzzy if it contains words which are labels of fuzzy sets, and P is vague if it is both fuzzy and insufficiently specified for a particular purpose. For example, Bob will be back in a few minutes is fuzzy, while Bob will be back sometime is vague if it is insufficiently informative as a basis for a decision. Thus, the vagueness of a proposition is a decision-dependent characteristic, whereas its fuzziness is not. Then for GRA, fuzziness means casualness, vagueness means imprecise fuzziness. Vagueness implies fuzziness plus lack of specificity. Now, there are so many MADM studies in the literature, 2DM, TOPSHIS, VCOR, GRA, Multimora, IDAS, ERAS, etc. So, uh, you may apply the new sets which are available in the literature. More than 80 need to be sets are available in the literature from need to be sets to pentapartition need to be sets, or you may further add component and define and use that sets in the new environment and use the like these strategies for new decision making problem or a medium problem or multi-attribute group thinking problem, and your new contribution will be evaluated and you will get credit. Okay. So, what is the importance of nucleotic sets? In nucleotic sets, we see that degree of truth, degree of falsity, and degree of independence are independent. Uh, but in real field, if you randomly collect data, you can have some result like this. Okay. So you can use the new sets, nucleotic sets, or intervallic sets, or pentavalent sets, etc., and use them for multi-attribute decision-making problems or multi-attribute group decision-making, etc. And for interval nucleotic sets, logic-based system, we can develop logic-based system on truth-valued. Okay. Then it is distributed to deal with practical applications in the areas such as information fusion, bioinformatics, military intelligence, web intelligence, etc. You can use the sets. These are references I have used. Thank you for patience. Actually, many Indians have developed and contribute in nucleotic sets. In this college have contributed a lot because you see, Professor D. Ajay has uh, contributed in the field of interval pentaval nucleotic graphs. With Baromi and Chelamanini and many researchers from India also, they developed interval pentaval graphs. I am very proud of that. They already interval pentapartition and graphs have developed by this institute. And I want to mention Dr. Diojoy here, presented here. He has done so good work, and our college is going to do with nucleotic sets. Many research has been done in our college also. This institute has done so good work, and I hope in future this college will cooperate with us, and I will also will cooperate with this institute for development of nucleotic sets and its various new applications. Thank you. Now, if any questions, please. If any question, please.
Sir, in pentapartition,